Hey guys, it's Czech from Czech DC-9 project again after a long time in recording a video from our DC-9er. Today I'm gonna talk about the APU and especially the EGT and about the pressure system that I've programmed recently. You see the APU is running and the EGT is slightly above 500 degrees centigrade. It's a little bit higher. Why? Because we have the left pack on, and so that means that the system is demanding air from the APU. Thus, the APU must run faster. Like if you add a thrust, you will also see a raise in the EGT in a normal engine. So that's working as a normal engine. If I turn the pack off, you'll see the temperature, the exhaust temperature will go down slowly. If I turn the pack back again, the temperature increases. If I turn on both packs, again the demand is much higher, so the temperature raises to almost critical. So always use only one pack. And also the cross feed valve, this one must be open. That's the valve between the APU and the system. If I close this valve, I got no pressure and the EGT will go down. Also now I cannot start the engine. If I turn the cross valve to open, and everything's back to normal. Now if I turn off the back and I will start the engine, again the demand is higher. I'll start it now and the temperature raises accordingly. So now I'm turning the engine and you see the temperature is very high. So very high demand of pressure means high temperature. Right. Now we go to this guy here. That's the pressure system. I'll go to the first officer's seat, and this is the cabin altitude, the outer scale, and this is the pressure difference. Now the difference is 0, and we've got about 2,000 feet, and on captain's altimeter the static pressure also shows 1,900 feet. Now if I now turn this knob to left or right, I can do anything to go to the right, to higher altitude, and nothing will happen because we cannot suck air out of the aircraft. But what will happen if I make it to, I don't know, 500 feet for example? This should start to do something because we can pressure the aircraft. We cannot pressure the aircraft right now because the supply are off. If I turn down that to auto, you will see the cabin pressure is starting to drop as we are pumping air into the cabin, and you see the different pressure is raising and the cabin altitude is going down because we are pressurizing it. Now what will happen if I open the door? This is the control lamp for the door. If I open the door, and the door should open any moment now. The doors are open and you see the immediate drop of the cabin altitude because we are back on 1,900 feet, and so that the cabin climb is very steep. And if I close the door, it will start to pump air back into the aircraft. Doors are now closed, and you will see the increasing of the cabin altitude. If I put it back to 1,900, it will start to climb again because we are going to that altitude, cabin altitude, and once it is there, the variable will start to show 0. You see, it's almost there. And if I make higher and higher, now that's 3,400, nothing will happen because we cannot suck the air out of the cabin. And of course, if you forgot to turn the packs on prior to departure, and you start climb with the packs off, the cabin altitude will follow the static altitude, as there is no pressurization. So that's briefly what we got new about the systems here. All other stuff there is working, and the projection is turned off now. And okay, see you next time, guys. Bye bye.